Welcome to Modulus Guys, your companion to strong foundation in conceptual learning. Let's get started. All right, boys and girls. Today we'll be talking about Excentre. We've already discussed Incentre. We'll now be talking about Excentre. So, guys, in this video, I'll be taking you through a very nice journey on geometry. So, please watch this video very carefully and keep making the notes also. And if possible, make sure you have color pens or pencils with you. Otherwise, the diagram that you will be making will be, kind of not looking very pretty after the video is over. Okay, guys. So, let's see. So, we have a triangle, guys. So, we have a triangle. So the topic is Excentre. So what is it? So guys, I told you if you are talking about internal angle bisectors, it is Incentre. Now let me extend AB. Let me extend AC. Got it? So this is the external angle bisector of B. External angle bisector. Got it? And here also I'm drawing. So wherever they meet, guys, this point is I1 for me. Got it? So these are external angle bisectors, right? Now, if you notice very carefully, this is angle B, this angle, right? So this will be 180 minus B. So this will be 90 minus B by 2. This will be 90 minus B by 2. Got it? This will be 90 minus B by 2. This will be 90 minus B by 2. Any problem in this? Similarly, guys, this will be 90 minus C by 2, 90 minus C by 2. So I hope this is very simple. Got it? So far, so good. Now, because I1 is drawn through the point of intersection of external angle bisector, it is expected that this will be equidistant from here and here. Got it? So let's say this is maybe P. Let's say this is Q. So it is expected that I1P by definition will be equals to I1Q. This is very much expected. And similarly, guys, I1Q will be equals to I1R also. Got it? So I1Q is I1R. Got it, guys? Now, this gives me an interesting thing, which is I1P is equals to I1R. Got it? Now that means I1 is equidistant from. So that means I1 is equidistant from. What does it mean? It is equidistant from line P and Q. So this is line P and Q. Right? Now that means line I1 lies on angle bisector of BAC. BAC. That means I can certainly say, guys, that if you draw a line from A, something like this will be I, right? Obviously, Incentre will lie on the angle bisector. I have very clearly now proven it to you that A, I, I1, they all lie in the same straight line. Now, this is the first super duper important thing, guys, that you really, really need to understand. Is this clear? A, I1, they are all in the same straight line, right? I repeat myself, I1 is the point of intersection of external angle bisector B and C. So because it is on the POI of the external angle bisector, because I1 lies on the external angle bisector, by definition of angle bisector, the distance of I1 from this line P and small q, this will be same. Got it? And if it is same, like from the distance of I1 from P and Q will be same, because this is one ray. Remember, this is the angle, right? And this is the bisector, right? So this distance and this distance will be same. And likewise, this distance and this distance will also be same. So I can say I1P and I1R are equal, and hence I can say I1 is equidistant from AP and AR. Got it, guys? So this is what we have, and hence it lies on the angle bisector BAC. Got it, guys? So this is very important. Now, once we have done this, then we can move further. This was the first super duper important thing that we I wanted to tell you. Now, let's move on. I'll be drawing the same diagram 2 3 times because I don't want to mess up one diagram. So this is the second diagram, guys. So second diagram means I'm drawing it again. So this is A. So extension. Now this is again extended, right? So I had mentioned it to you guys that there will be a circle that you will have, right? This is in circle. Similarly, guys, there will be another circle that you can draw, right? Which will be going like this, right? There will be another circle, right? With I1 as the center. So this is I, got it? So let me just draw this. So from AI, as you can see, this is the thing. Already I have proven that this is a very much possible diagram. I hope there is no problem in this. Got it? Now, I had told you in my last lecture on Incentre that from here to here, if whatever is this distance, right? Let's label the triangle first, B and C. So from Incentre, let's say this is maybe X, right? This is X. Now from X center I1, also I can drop a perpendicular, which will be going like this, right? So this is what we have. So this will be perpendicular as well. So let's say this is X1. Any problem in this, guys? Any problem whatsoever? Easy peasy. So this you can call it as maybe M. Let's say this is N. Wherever the circle is meeting, this is N. Now, there are a lot of important things, guys, that you really, really need to understand on this now. Okay. So I'm starting it. So I1X, right? I1X1, this is what we now see. Understand this. First thing we need to understand is X and X1 are isotonic points. Now, what does that mean? Now, X and X1 are isotonic points. It means both the points will be equidistant from the middle point of BC. Wherever is the midpoint of BC, both these points will be equidistant. Is this clear? Now, let's understand this. See, there is no doubt in writing this that this will be C, right? That this will be B. Got it? In my previous lecture, I have already proven it to you that this is S minus B. Got it? Is this clear? Any problem whatsoever? Now, from B. Now, see, if you notice carefully, this maroon circle or the purple circle is touching BC at X1. So, length of the tangent from an external point are equal. I can very comfortably say, guys, that BM is equals to BX1, right? Length of the tangent from external point is equal. Any problem? Now, if you ask me what is BM, see, BM, if you notice, BM is equals to BX1, right? What is BM? BM is nothing but, what is BM, guys? BM is nothing but AM minus AB. So this is BX1. Now AM will be smallest. AM is smallest. And what is AB, guys? AB is C. So BX1 is S minus C for me. BX1 is S minus C for me. So I hope, guys, this is very clear. So let me label it for you. From here till here, this distance will be S minus C. I hope this is very, very clear to you. Any problem whatsoever, right? Now, in a very similar mannerism, guys, now AN, if you talk about the other side, even this will be S because length of the tangent from external point is equal. So if AM, if this is S, if this is S, then certainly AN will also be S. So I can say Cn is S minus B. And if Cn is S minus B, Cx1 will also be S minus B. I hope, guys, this is very, very clear. There is absolutely no problem. Yes. Now, see, I don't know where is the midpoint of BC. Let's say somewhere down the line, there is a midpoint which is here, right? Somewhere down the line, there is a midpoint which is this. Is this clear? So if x and x1, if they are isotonic points, what I would like to establish is that dx is equals to dx1. That's what I would like to establish. Got it? If it is okay, then I'm done with it. So guys, dx is how much? Bd, which is a by 2, minus bx, that is s minus b. Got it? Bx is s minus b. Any problems whatsoever? And similarly, guys, what is dx1? Dx1 is c d. cd is how much, guys? Cd will be how much? Cd will be how much? A by 2 minus cx1, which is s minus b. So you see, directly we can observe, right, that both are equal. So we can say that yes, both the distances are equal, and hence x and x1, they are isotonic points. If you want to figure out the distance x1, that we can figure out bx1, right, minus I think bx. So what is bx1? Bx1 is s minus c, already done, and s minus b. So this will be, in this present situation, b minus c. That's what we can write as x1, although we won't be using it much. Is this clear, guys? So therefore we say this x and x1, which is the foot of the perpendicular drawn from Incentre and Excentre I1 on BC respectively. Got it? I hope, guys, this much is very clear. Now, in this entire thing, what you may not have understood is why AM is S. Although I have already covered it, but still I'll cover it once again. I've covered it in another video, but I'll cover it again, right? So see this. So if you have a triangle, this, right, and you, this is the circle, right? So this is A, B, C. This is M, and this is N. Got it? So AM is expected to be S. That's what we, right? How and why? See, if you see AB plus BC plus AC, how much will be this? See, this is the perimeter of the triangle, right? Now let's say this is maybe whatever, maybe D. Got it? So this is AB plus BC is BD plus CD plus CA. So guys, what is AB plus, now BD is equivalent to BM, because length of the tangent drawn from an external point is equal. So plus CD is CN, same logic, and CA is CA. So guys, this is AM plus AN. Again, length of the tangent from external point is equal. So we are getting 2AM. But what is this? This is the perimeter, right? So this is the perimeter. So AM is perimeter upon 2. What's that? Semi-perimeter. So AM, guys, is therefore S. So I hope you have been able to understand why that was labeled as S. Now let me do a bit of a basic geometry in this. So let's understand this. So guys, now I can erase or let it be. So there is a, this is what we have, I1, this is I, right? Now this is what we have as 90 minus b by 2. This is 90 minus b by 2, and this is b by 2. Got it, guys? So one thing that we need to understand is that this angle will be 90-degree. That we already understand. Internal angle bisector and external angle bisectors, they are always perpendicular. So but still I have established that this green shaded region is actually a 90-degree angle. Got it, guys? So I hope this is very, very clear. There is absolutely no problem. And I can also draw this perpendicular, right? This is a by 2. right? So in triangle AI1M, it is easy to say tan A by 2 is, this is R1. Got it? R1 upon AM, which is S. Are you getting my point, boys and girls? So tan A by 2 will be R1 upon small s, right? Any problem in this? Any problem in this? In the same triangle, guys, if you use sine A by 2, what is sine A by 2? Opposite side, which is R1 and AI1. So, guys, AI1 can be returnable as R1 cosecant A by 2. So, this is also a very important relation, the distance of the vertex A from the X center. Got it, guys? Similarly, we can understand BI1. We can also understand CI1. Got it, guys? So similarly, now we'll do one more thing, which is, see, area of ABC. How will you write the area of ABC? Area of ABC can be written as area of ABI1, ABI1, right? Let me highlight it for you. I'm talking about this area, right? Similarly, area of ACI1 minus area of BCI1. Got it? So ABI1, if you notice, is how much? Half into base into height. So this is half into base is AB. So there'll be C. And the perpendicular distance will be R1 plus half into B into R1 minus half into A into R1. Got it? Like if you talk about the area of triangle BCI1, then how will you write the perpendicular? I mean, you have to join like this, right? And this is nothing but R1. Got it, guys? So now area of the triangle remains delta. So delta is half common, R1 common, B plus C minus A. So guys, what is this? Delta. So may I, if you allow me, multiply by 2 and divide by 2? Or we can do it directly also. There is no problem. So this is, now what is B plus C minus A? See, we understand what is B plus C minus A. See, A plus B plus C is 2S, right? That is the perimeter, right? So B plus C is 2S minus A. Subtract one more A. So this will be 2S minus 2A. So this is what we have. So guys, this 2 will cancel and you can say that delta is equals to R1 upon S minus A. So guys, this is yet another very important formula that we have. Any problems in this, guys? Any problems whatsoever? I hope this is very, very clear. Easy. Now, see, currently in this entire episode, I have been drawing only one circle, X circle, which is opposite to A. But eventually, if you see this as a proper picture, this is one triangle, this is one ABC, right? Then you have to extend the sides, right? So when you extend the sides, right? So that's what we have. So similarly, guys, now there will be, like, I can extend on the other side also, right? So this is the complete thing, right? So if this is A, this is B, this is C. Now I would like you to understand how angles are going on, right? So let me just draw this. So guys, this is my angle bisector. So this is somewhere here, we can label I. This I1 will be somewhere here. Any problems in this? Got it? Circles I'm avoiding to draw because circles will not look good. So this is your one external angle bisector. This is another angle, external angle bisector. Got it, guys? Any problem in this? Easy. Now at the same time, now if you notice, guys, this is 90 minus b by 2, 90 minus b by 2. So let me extrapolate this line backwards also. Like if I extrapolate this backwards, right? And similarly with A also, let me just draw angle bisector. Like this is It's going backwards. So let me draw angle bisector. So this will be right. This is what's happening. Got it? Now, if you notice, because this blue line and the purple line, like if you notice, this will be 90 minus b by 2. Is this clear, guys? Any problem whatsoever? This is b. So if you notice this entire angle is 180. It's very clearly visible. So therefore, we expect this point like I2, I3, sorry. Now this will be a straight line. I3, B, I1 is expected to be a straight line. It's making a 180-degree angle. It's clearly visible, right? And then similar story will be done on the other side of A. So this is what we have. And we can extend it like this. Got it? So this will be I2. Is this clear, guys? I hope this is very, very, very clear, right? Now, I have already proven it to you that A, I1, they are collinear. Similarly, guys, B, I2, C, I3, they will also be collinear. There is no doubt about it, right? So anyways, we'll stick to this. So guys, if you see, we can draw perpendiculars from I1 on like this. So this is one perpendicular and this is another perpendicular. Got it? So guys, this will be 90-degree. This will also be 90-degree. Any problem whatsoever? This is A by 2. This is A by 2. Easy. There is nothing to explain in this. This is all self-explanatory, right? Now this is 90 minus C by 2. Right? Now, if you notice very carefully, guys, I am now interested in few things. Right? Now, if you notice, this is R1. Right? I hope this is very clear. Now, I would like to understand what is this angle. I would also like to understand what is this angle. Got it? Now, see, if you notice, let's talk about this A, B, I1. Got it? Let's talk about this. Now, in this triangle, it's very evident that this part will be like 180 minus A by 2 plus 90 plus B by 2. Why? Because B minus B by 2 will give you plus B by 2. Got it? So guys, this will be 90 minus A by 2 plus B by 2. This is absolutely simple. This will be C by 2. Because in a triangle, A by 2 plus B by 2 plus C by 2 will be 90. Right? Likewise, I can say, guys, that this will be B by 2. Got it? So put together collectively, guys, if I have to say, this angle will be how much? 90 minus A by 2. This total angle that you have, I1 will be 90 minus A by 2. I hope, guys, this is very, 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 very clear. I hope there is absolutely no problem. So far, so good, guys. I hope this is very clear. Now, if you may join B with I, right? And I with C. If you notice this also, in the Incentre also, you can prove it again also, but like otherwise no need. It's up to you. See, this angle we had proven is 90 plus A by 2. This angle. You can establish it without going to that video also. You can easily find this by external angle property of the triangle, like A by 2 plus B by 2. And similarly, this part will be A by 2 plus C by 2 from here. So from there, it's easy to say this is 90 plus A by 2. So guys, if this is 90 plus A by 2, this is 90 minus A by 2. It is very, very clear from here, guys. The first point of observation that I wanted, that B, I, C, I1, it is a concyclic quadrilateral. You must observe this. It is a concyclic quadrilateral. I hope, guys, you're able to understand this. It's a concyclic quadrilateral, super duper important. Got it? So this is very important. So I have been able to establish, guys, I1, I3 is a straight line. I have been able to establish I1 similarly. I1, I2 is a straight line. And similarly, I2, I3 is a straight line. So we have now this triangle that you're getting, I1, I2, I3. This is mathematically known as X central triangle because it is formed by three X centers. I hope, guys, there is absolutely no problem in this. Easy whatsoever. Now, my next arguments will be in B, I, C, I1. This is where I'll be arguing further. So, just to tell you, what am I up to? See, I would like to figure out what is I1, right? I would like to find out what is the distance of in center from X center. I would like to find out that. I would also like to find out what is the distance of A from I. I would also like to find out what is the distance of A from I. All these things, guys, I need to find out. Are you getting my point? So let's see. All right, guys. So let's see then. Um, See, we have already understood that angle wise. I'm just completing these angles which are left out. So this is B. This is 90 minus A by 2. Right. This is also 90 minus A by 2. So see, it is very evident from here that this angle total is 90. So that means A I1 or I1A. It is very evident, guys, that I1A is perpendicular to I2 I3, right? Similarly, if I say C I3, this will also be perpendicular to I1 I2, right? I mean, to demonstrate it, like this is what we have, and C I3, C I3 will be perpendicular. That is easy to note, right? Any problem? Because you see, this is C by 2, no? So this is going to be 90. Got it? So guys, now in this triangle, in triangle C I1 I3, right? Now I have already established this is 90 minus A by 2. This. Got it? So secant A by 2, right? Secant A by 2 is hypotenuse, which is I1 I3, divided by the base, which is C I1. Got it? Secant 90 minus A by 2. Sorry. Secant 90 minus A by 2. Got it, guys? So this will be cosecant A by 2 or sine A by 2. Other side, I'll be reciprocating. So, guys, this is very important thing that we have. Now, what we can understand is, see, I've already told you that this angle is 90 minus A by 2. So how much will this angle be? 90 minus B by 2. Yes or no? So see, guys, triangle I1BC is similar to triangle. Now I1, now see this, if you look into this angle, how much is this angle? 90 minus B by 2. How much is this angle? 90 minus B by 2. So that means whatever is this angle CBI1, CBI1 is same as this angle I2. So instead of B, I'll put I2. And instead of C, I'll put I3. So got it, guys? This should be I1. I have put a triangle symbol. So this is triangle I1, I2, I3. Got it? So if you put similarity condition, like I just want the diagram to be on the screen for you. So I1 B upon I1 I2. This is BC upon I2 I3 and C I1 upon I1 I3. Got it? Now see, C I1 I3 is already known to me as sine A by 2. Got it? So this is sine A by 2. So guys, what is BC? Right now, this is purely theoretical. So this is A upon sine A by 2. This is I1, I2, I3. So what is this? This is 2R sine A divided by sine A by 2. So which is 2R, 2 sine A by 2 cos A by 2. Got it? And divided by sine A by 2. So this will cancel and you will be getting I2, I3. I2, I3 is 4R cos A by 2. Is this clear? Similarly, if you want to find out I1, I3, you can get 4r cos b by 2. And like I'll write it only, I1, I2 will be 4r cos c by 2. And similarly, I1, I3 will be 4r cos b by 2. Got it, guys? I hope there is absolutely no problem in this, right? This is easy, guys. So far, so good. Now, let us go further. Now, I am also interested in finding the distance between Excentre and Incentre. That is, what is I1? For that, guys, as I said earlier, I would require the concyclicity of B, I, C, I1. Is this clear? You see, B, I, C, I1, they are concyclic points. Got it, guys? So, shall we proceed? Okay. So, I think, I hope you've written this all, or let me see. It's good if you write it, that'll be easy, right? Or I can move it down. Got it? So, because I need this diagram on the screen. Got it? So, see, I1, if you notice very carefully, IB is making a 90-degree with I1, I3, right? I mean, this angle is 90-degree. This angle is 90-degree. Yes or no? And the concyclic. So that means I1 can serve as a diameter. This is the diameter. Is this clear? So any chord is equals to why I had already mentioned it to you, is equals to the diameter of the circumcircle. Diameter of circumcircle in sine rule I had taught you this, right? Into what? Into sine of the opposite angle, right? Now opposite angle over here you can take it as sine of opposite angle, which is 90 minus a by 2. You could have taken this also, I also. Same thing, doesn't really matter. So, guys, from here I can say what is BCA. Diameter of the circumcircle is I1. And this is into cos A by 2. So, guys, what is A? 2R sine A, right? What is sine A? 2 sine A by 2 cos A by 2, which is I1 cos A by 2. So cos A by 2, cos A by 2 cancels. And guys, I've been able to establish I1 is equals to nothing but 4R sine A by 2. Guys, this is the distance between Incentre and Excentre. Got it? Any problem whatsoever? I hope this is simple, guys. So I told you I would like to calculate AI, BI, CI also. So now in this triangle BII1, you can already see what kind of diagram I'm having, right? So if you look into this triangle, guys, BII1, right? So let's say this angle is C by 2, 90 degrees also available. So I need hypotenuse and I need opposite side. So sine C by 2. Sine C by 2 will be BI upon II1. Got it? Now, guys, what is I1? That is known to me. 4R sine A by 2. So, done. So, what is BI? BI will be 4R sine A by 2 sine C by 2. Likewise, guys, I can write AI is equals to 4R sine B by 2 and sine C by 2. And CI can be written as 4R sine A by 2 sine B by 2. Got it, guys? So these are some of the important points that I wanted to tell you. Shall we go further? It's not over. It's not over. We have still few things left, right? So shall we go further? All right. Let's see. Now we'll be working out with Incentre, Excentre, Lemma. What is the next story, guys? Now we'll be talking about Incentre, Excentre, Lemma. So diagram, I don't need that complicated diagram. So we can move on. Incentre, Excentre, Lemma. So what's that? Now see this. See, suppose we have a triangle, right? We have a triangle. Now this is, let's extend this. Now already I have told you that A I1, they will lie in one straight line. So this is I, right? So guys, we already know that B, I, C, I1, there is a circle that can pass through these 4 points, right? So let's draw that. There is a circle passing through these 4 points because they are concyclic, already taught to you, right? Now there will be a circumcircle of ABC also, right? So what we need to understand, guys, is let's say this circumcircle is intersecting, or you can say circumcircle is intersecting this AI1, this internal angle bisector at L. Is this clear? So what does this theorem, what does this lemma tells you? This tells you guys that L is the circumcenter of the red circle of circle passing through BICI1. Got it? How can you establish this? For that, let me draw these complete circles so that you have a better visibility. Because dotted lines are not very nice. So guys, this is the complete circle. And this is the yes or no. So I'll be proving it to you. Now the proof is very simple, guys. Now let's join BL. So how will you establish, guys? So let's join BL. Join BL. So guys, I'll prove it to you that BL or LB is equals to LI. And I'll also prove it to you that LI similarly is CL. So that means all the three distances will be equal, right? All the three distances would be equal, the CL. I'll prove it. So that means this point L is equidistant from 3 points, right? So that means it has to be the circumcenter, because by definition, circumcenter is the point which is equidistant from all the vertices. Are you getting my point? We have a circle passing through BIC and there's a unique circle, right? So that is how my approach would be. So guys, if you see LBI1, LBI, not I1, LBI, right? Now, see this LBI, angle LBI is equals to angle 1 plus angle 2. Like I have this angle, right? I have this angle. Now, this angle, if you notice this is the chord. Now, this chord is making one angle here, and this chord is making another angle right up here. So that means very clear if this is angle 1 and this is angle 2. Now, angle 1 is expected to be A by 2, angle in the same segment. If this is A by 2, then this will also be A by 2. And angle 2 is very clearly B by 2. That does not require any explanation. I hope, guys, this is very, very simple. Now, similarly, guys, if you talk about angle BIL, if you talk about this angle is directly external angle in this triangle. In this triangle, AB I1. In this triangle, this is external angle. BIL is external angle. So what will this be equals to? This angle which is A by 2 and this angle which is B by 2. Right? So this is directly, you can say, A by 2 plus B by 2. So you see, guys, I have been able to establish that LBI, this angle and this angle, they are equal. Done. So that means the sides opposite to equal angles are equal. So that means BL is clearly equals to LI, right? So this is done. Likewise, I can also establish cut copy paste method that CL is equals to LI. That means the distance of a point from the 3 points is same. The 3 points are on the circle. So L has to be your circumcenter of the circle passing through BILI1. Or you can also say L is the midpoint of the arc BC. Got it, guys? Yes or no? L will be the midpoint of the arc BC. Any problem in this? Now, this in-center Excentre theorem is also known as the Trillium theorem or chicken foot theorem. Okay, but then it is most popularly referred as in-center Excentre lemma. So we've done it with that heading only. Got it? So this is what we have in Excentre, guys. Understood?
So I hope you've understood the topic, boys and girls. Please don't forget to like, share, and subscribe my YouTube channel. And don't forget to press the bell icon to get my latest videos. See you guys. Bye-bye.